This is a video on the area of a triangle. There are several formulas how to calculate the area of a triangle. This particular one is when we work with the coordinate systems. So we have coordinates, yeah? Okay, so this formula only works if one of the points is 0, 0. Yeah, so one of the vertices of the triangle needs to be at 0, 0, which means we are then left with 2 points that are not 0, 0. So here we have the formula. So the area is 1/2 of the modulus of x1 times y2 minus x2 times y1. So remember, one of the points needs to be 0, 0, and then we are left with 2 other points, and then they become part of the formula. So also this is what we call the modulus, or also the absolute value, which means even if we get a negative value within those straight brackets, then we just turn it positive. Yeah, we just use whatever negative value we get in there, we just use the positive value. So we'll look at an example here. Okay, find the area of the triangle with vertices 0, 0, minus 2, 1, and 3, 4. So as we see, one of the points is 0, 0. So this is what we're looking for, and then we are left with 2 other points. And again, we label it x1, y1, x2, y2. And we put that into the formula. The area is 1/2 the modulus, so x1 minus 2, so brackets around it, times y2, which is 4, minus x2, which is 3, times y1, which is 1. So we just literally put in the values, and then we calculate it. It's 1/2 the modulus of minus 8 minus 3, and then we get 1/2 the modulus of minus 11. So the modulus of minus 11 is just 11. Yeah, so we just go 1/2 and no more straight brackets, 11. Yeah, so remember, the modulus of minus 11 is just 11. So there'll always be a positive value, and that is just 5.5 squared units. Okay, so what do we do if the triangle is not at 0, 0? So as you can see here, if we shift the triangle, we just shift it, then the area stays the same. And this is what we will use here for the calculation of the area of the triangle. Okay, so we have 3 points. 2, 4, 7, 3, and 4, 1. 4, 1, yeah, so 2, 4 is this point, 7, 3 is this point, 4, 1 is this point, and now we translate the whole triangle so that one of the points is at 0, 0. It doesn't matter which point we pick, just pick the one that you consider the easiest. So if there's already a 0 in the coordinates, pick that particular point. So, but we decide to move the point 2, 4 to 0, 0. So I'll write 0, 0 down here and see what did we do. So from the 2, I had to take a 2 away, so minus 2, and from the 4, I had to take 4 away, so go minus 4 in order to get to 0. Yeah, so 2 minus 2 is 0, 4 minus 4 is 0. So now I have to, in order to not change the shape of the triangle, it has to be exactly the same triangle. We do the same transformation, the same shift to the other points. So 7, so again minus 2 and minus 4. Minus 2 for the x value, minus 4 for the y value. So 7 minus 2 is 5. 3 minus 4 is minus 1. So that would be this point, yeah? So we shifted 7, 3. We shifted 7, 3 to 5 minus 1. And we do the same thing now to the third point. We take away 2 away from 4, and we take 4 away from 1, which leaves us 4 minus 2 is 2, and 1 minus 4 is minus 3, and that would be then this point. So we shifted this point. So now we shifted the triangle, and we have now one point at 0, 0, which means we can now use the formula. So let me write that down again. So it is 1/2 the modulus of x1, y2, x1, y2 minus x2 times y1. So just across, just the opposite always. And we take the modulus of that. Okay, so area equals 1/2 modulus. So let's label our points. So not the 0, 0, but the other two. So x1, y1, x2, y2. And now I put that in. So x1 is 5, y2 is minus 3, minus x2 is 2, and y1 is minus 1. Okay. So A equals then 1/2 minus 15 plus 2, which leaves us with 1/2 the modulus of minus 13. And remember, whenever we have the modulus of a negative number, we just turn it positive. Yeah, so the modulus of minus 13 is just 13. So we have 1/2 of 13, which is 6.5 units squared. So what do we do if we get a question like this? So we are given the area already, and we have to find one of the variables. So the triangle is at 0, 0, which is good, so we don't have to shift it. Okay, so let's write our formula again. 1/2 x1, y2 minus x2, y1. And we fill it in. First of all, we label our points x1, y1, x2, y2. Okay, so we know that the area is 7. We are given that. 7 is 1/2. X1 is 4. Y2 is k. Minus x2 is 6. Y1 is 3. And it's the modulus of that. Okay, so we simplified a bit. So first of all, we multiply by 2 to get rid of the 1/2. So we multiply by 2. That gives us 14 modulus of 4k minus 18, and it's the modulus. So now here we are told find the values of k. So there's going to be at least 2k. And the reason why is because there's two situations. So first of all, whatever is in here could be positive, and whatever is in here could be negative. And it would give us the same value. It would give us 14 because those two bars tell us we just turn it positive. If it's positive, we don't have to change it. If it's negative, we change it to positive. So that gives us two situations. So the first situation is that it's whatever is in there is positive. So 4k minus 18 equals 14. So we can calculate that now. 4k is 14 plus 18. 4k is 32. That gives us a k of 8. And now the whole thing could be negative. So we would write that as 4k minus 18. The whole thing could be negative. And so we write it as minus 14. So, and then we calculate that as well. Okay, so we go 4k is minus 14 plus 18. 4k is minus 4. And that gives us a k of 1. Yeah, so these are the two situations. So in a modulus, if it's positive already, it keeps it positive. If it's negative, it turns it positive. So that gives us two situations. Yeah, so that whatever is in there in those brackets is positive to start with. So that's why we write down 4k minus 18 equals 14, or whatever is in those two bars is negative, and only then do we turn it positive. So, and we have to account for that situation as well. That's why we calculate 4k minus 18 equals minus 14. And then if we calculate the k, so for the positive situation, we get k equals 8. For the negative situation, we get k equals 1. So if we put that in the k, we put the k back, so that would be 4 times k minus 18. That would be 4 times 1 minus 18 is minus 14. And then because of the bars, the modulus of the minus 14 would be positive 14. So we would have to account for this situation as well.